my name is Isabel Navarro, and today I will be discussing how do planetary nebulae get their space within space, as the answer has been unknown until just recently. To begin, what are planetary nebulae? Well, they are a type of emission nebula with a growing shell of ionized gas that glows various colors brightly within space. From this, astronomers are able to visually see different shapes. Nebulae are often old in age, and the ionized gas we see in the pictures gets released by red giant shells. As the luminous gas gets released from red giant stars that are dying, they then exhibit all of the different colors as well as shapes I was referring to previously. So how do astronomers find the shape of planetary nebula? Scientists decided to take a look back into the history of stellar evolution process. The stellar evolution process. The answer lies within the asymptotic giant branch stars in space. They are cold red giant stars which can stretch to the size of Earth's orbit. These asymptotic giant branch stars glow 1,000 times brighter than the sun. The distribution of carbon from within the core of the stars resulted in the effect of a colorful nebula. Finding shapes continued. Asymptotic giant branch stars end up losing high amounts of mass, which then gets in the way and blocks any activities occurring close to the stars. With this being said, this made astronomers second-guess the idea of low-mass stellar evolution, as asymptotic giant branch stars were experiencing such short lifespans, causing them to ask more questions and discover how these stars were created. Asymptotic giant branch stars basically refers to stars lying within the region of the Hertzsprung-Russell diagram, where there are plenty of cool luminous stars found in one region of the diagram. The ALMA telescope, which is the largest telescope in the world for radio waves, in order to find the shapes, astronomers in Chile use the Atacama Large Millimeter Array Telescope, which is shortened with ALMA. This telescope has the ability to push past any gas or dust surrounding the star in order to study wind patterns and observe the true shapes of the nebula. So, how do winds impact the shape of a planetary nebula? The ALMA telescope provided evidence how none of the winds were symmetric. This was the explanation as to why so many different shapes were present within the planetary nebula. The wind speed affects the star. As it loses more mass, it helps to determine how wide an orbit will become. Stars with weak winds are closer companions, whereas stronger winds are further apart from each other. So what are the shapes produced? There are several different shapes produced, some of which include spirals, which can be seen in the middle picture, roses, which I have on the bottom picture, butterflies, which I'll be showing on the next slide, helix, cat's eye, which is the top, and diamonds. Here are just some more pictures that I found for you guys. I have the horse head, which is in the first picture. You can kind of see the shape of the horse, and its head in the top cloud, and like its body, kind of. And then in the second picture, I have a butterfly, which kind of looks like butterfly wings, with two wings stretched to the side. Alright, I hope you guys enjoyed, and here's my question.